Okay, so in this video we are going to be talking about concentration and molarity. Okay, concentration and molarity and how we can determine these things. Okay, how we can determine these things. So in the first question, they're saying that 30 grams of sodium hydroxide was dissolved in 20 centimeters cubed of a solution. Okay, so 30 grams of sodium hydroxide was dissolved in 20 centimeters cubed of a solution. And the first question that they're asking us here is that calculate the concentration. Okay, calculate the concentration of the same sodium hydroxide. I know I never just completed it, but they want us to calculate the concentration of the sodium hydroxide. Now, one thing that you need to understand is that concentration can be expressed in two ways. It can be expressed in terms of grams per decimeters cubed, or it can be expressed in terms of moles per decimeter cubed. Okay, so it can either be grams per decimeters cubed or moles per decimeters cubed. It is from this same concept that we can even define concentration in two ways. Concentration can be defined as the amount of a substance dissolved per liter of a solution. Okay, the amount of a substance or amount of a solute dissolved per liter of a solution. Now, when you're talking about amount of a substance, amount of a substance can be also, can I say, directed in two ways. Amount of a substance can either refer to mass or it can refer to the number of moles. Okay, so amount of a substance can be directed in two ways. It can either be referred to as mass or the number of moles here. Because even if we are defining mass or matter, you're going to find out that there is always this aspect of amount of something. Like a good example, when you're defining matter, you're going to be like matter is, or rather, let me say mass. You're going to be like mass is the amount of matter in a substance. That's how we define it. There is that concept of amount there. If we are talking about a mole, how do we define a mole? A mole is just simply any amount of a substance that contains as many elementary particles as there are in 12 grams of carbon-12. But the simpler definition of a mole, you can just say that a mole is just any amount of a substance that contains 6.02 times 10 to the power 23 particles, where particles can refer to either ions, atoms, or molecules. So from the definitions of mass and the mole, you're going to see that there is always this amount aspect that is involved. And we're saying here that concentration is just simply the amount of a substance or amount of a solute dissolved per liter of a solution. So amount of a substance or amount of the solute here can either refer to mass or the number of moles. That's why you're going to see that we're expressing concentration either in grams per decimeters cubed or moles per decimeters cubed here. Now, let us begin. If you notice, in the first one, they're saying calculate the concentration in grams per decimeters cubed. Gram here is just simply a unit of mass. Okay? But before you do anything, it's very much important that you make your conversions. If you notice, the volume value that has been given here is 20 centimeters cubed. And we are seeing here that they want us to express our concentration in grams per decimeters cubed and in moles per decimeters cubed, which means that your volume value should be converted in decimeters. That's the whole reason why I have written a point for you to say convert the volume, which is in centimeters cubed, to decimeters cubed. You're supposed to convert that. How? Notice how is it that this is our volume, 20 centimeters cubed here. We know by now that 1 decimeter cubed, 1 decimeter cubed, which is just the same as saying 1 liter, is always equivalent to 1000 centimeters cubed. And 1000 centimeters cubed, I mean, this is just the same as saying 1000 milliliters. So if someone says decimeters cubed, liter, centimeters cubed, milliliter, they're just talking about one and the same thing. Decimeters cubed is just the same as liter. Centimeters cubed is just the same as milliliter. So don't let this confuse you. Okay? So this is what I've just done. I introduced a conversion factor here. We saw that this was 20 centimeters cubed. So 20 centimeters cubed was just multiplied by 1 decimeter cubed over 1000 centimeters cubed. Why in this way? So that the centimeters cubed units can cancel out each other. So when the centimeter cubed and the centimeter cubed cancel out each other, we're only going to remain with the 1 decimeter cubed or the decimeter cubed units there. And of course, if we proceed in this way, our value is just going to be 0.02 decimeters cubed. But again, if you're finding it maybe finding it a hard time maybe or a challenge to do that, just do it in the usual way. 1 decimeter cubed is equivalent to 1000 centimeters cubed. In the usual way, you bring your 20 this side, you write your x here, you do your cross multiplication. This is going to be 1000x, and then 1 times 20, of course, this is just going to be 20 over 1000 over 1000. It's fine. You're still going to get your value as 0.02, I believe, decimeter cubed. So you can choose to go in this way, or if you want, you can just try out something new whereby you just introduce your conversion factor, and I mean, it's still going to add up. Okay, so once we determine our volume value in decimeters cubed, we will now proceed to tackle or answer these questions that have been given. So judging by the way the units are, grams per decimeters cubed and mole per decimeter cubed, we can have 2 formulas for concentration here. Concentration can be mass over volume, provided that your volume is in decimeters cubed. Or concentration will be equal to number of moles over volume, again provided that your volume is in decimeters cubed. Okay, so the easy one, of course, is the first one, and direct even. Concentration will just be equal to mass over volume here. The mass that has been given is 30 grams. No need for you to start converting this value in kilograms, because initially this is what you were given, grams per decimeters cubed. No need for that consideration of SI units here. Just go with the 30 grams there. So that's going to be 30 grams divided by 0.02 decimeters cubed, which when you're with your calculator and after you punch in your values, the value of your answer is just going to be 1500 grams per decimeters cubed. It's a direct one. You just get your mass value, the 30 grams of the sodium hydroxide that was given, you put it there, the volume that you had determined in decimeters cubed, you put it there, and that's it. You're going to have your answer in that way. The one maybe that might be a little bit involving is this one, which is involving the number of moles. Concentration is equal to moles over volume. That is okay. But we do not know the number of moles, which means that before you do anything else, it's imperative that you first determine your number of moles here. And of course, the number of moles here is just going to be equal to the mass over molar mass. That's the formula for number of moles. Mass over molar mass. Your mass has already been given. That's the 30 grams that we're seeing there. But unfortunately, your molar mass should be determined. How are we going to determine our molar mass? Well, on our periodic table, it's evident enough to see that sodium has a molar mass of 23. Oxygen has a molar mass of 16. Hydrogen has a molar mass of 1. There is 1 sodium atom one oxygen atom and one hydrogen atom in our sodium hydroxide. So in order for us to determine our molar mass here, we're just supposed to add these values directly. That is 23 plus 16 plus 1, which is going to give you 40. So this is what we did. So this is going to be 23 plus 16 plus 1. And take note, molar mass has units. The units for the molar mass are the grams per mole. That is why molar mass can be defined as the mass of 1 mole of a substance. So your molar mass, unlike your relative atomic mass and your relative molecular mass, your molar mass always has the units referred to as the grams per mole. So 23 plus 16 plus 1 grams per mole, which is just going to give you 40. So 30 grams divided by 40, the answer is going to be 0.75 moles here, as you can see. 23 plus 16 plus 1 is going to give you 40, so 30 divided by the 40, the answer is going to be 0.75 moles. Once you determine your number of moles, you now just get this value and then you're going to substitute it on the mole expression here. You have found your number of moles, which is 0.75, so you're going to make a substitution. That's the whole reason why you're going to see me write saying C is equal to 0.75 moles, the number of moles that we had determined here, divided by the volume, which is 0.02 decimeters cubed, like we had initially converted to here. So 0.75 divided by 0.02, your value is just going to be 37.5 moles per decimeter cubed. Then that's it. You have determined your concentration in moles per decimeters cubed. And then in conclusion, I want you to understand that there is another way in which you can express your 37.5 mole per decimeter cubed. There is a special unit that we introduce here which we call the molar. That's the whole reason why, if you want, you can say 37.5 mole per decimeter cubed or 37.5 molar. So one thing that you need to understand is that 1 molar is equivalent to 1 mole per decimeter cubed. So when you're talking about concentration, like we had said, concentration can be expressed in 2 ways, either in terms of mass or in terms of moles. We saw that if the concentration is expressed in terms of mass, the units are going to be grams per decimeter cubed. But if your concentration is expressed in terms of moles, we saw that it was mole per decimeters cubed, or the molar. There is a special type of concentration here. That concentration that is expressed in terms of moles, that type of concentration that is going to be expressed in terms of moles or mole per decimeter cubed, that type of concentration is what is referred to as molarity. So there are people that normally find it a challenge to differentiate between concentration and molarity. Concentration can be defined generally as the amount of a solid or amount of a substance dissolved per liter of a solution. But when you're talking about molarity, molarity is defined as the molar concentration of a substance, or that type of concentration that is expressed in moles per decimeter cubed. So this type of concentration that is going to be expressed in terms of moles or mole per decimeter cubed or molar, that type of concentration is what is referred to as molarity. So that's how you can make a distinction between concentration and molarity. One more time, concentration is just the amount of a substance or solid dissolved per liter of a solution, generally defining it. But when you're talking about molarity, molarity is the molar concentration of a substance or that type of concentration that is going to be expressed in terms of moles, that is going to be expressed in moles per decimeter cube or molar. That's what we're going to be referring to as the molarity. So I hope this first video helps um, in trying to determine the concentration or molarity of a substance. This is just the first. There are others that are going to be released emphasizing more on these things, concentration and molarity. So thank you very much for watching.